Okay, let's start. This is section 10.1 and our first topic is the parametric equations of a curve. Okay. Uh, Before this, I would like to recall from calculus 1. For example, in the calculus 1, let's say this is our function which is written in this form y equals to f of x, but there are some conditions that this can be a curve, but it should be written in this form. It has to be a function, but there are some other curves which cannot be written in this form. For example, think about this circle. Okay, or for example this type of curves. These curves cannot be written in this form, so what we do, we write them in the parametric equations. For example, x equals to f of t, y equals to g of t, and t is the parameter which varies from, let's say, alpha to beta. Okay, but the main point we want to discuss here, for example, if we want to find the equation of a tangent line to a given curve, a parametric curve, how can we find this thing? Okay, so this is our first topic that we are going to discuss here. We want to find the equation of tangent line. We want to find the equation of a tangent line to a parametric equations. For example, how do we find the equation of a tangent line? The equation of tangent line, it is given by this y minus y1 equals m into x minus x1. For example, suppose that here we have a point, this is our point, and its coordinates are given by this x1, y1, and we want to find this tangent line. And in order to find the tangent line, we require two informations: the point at which this is tangent to the curve, and also we need the slope of the tangent line. And the next question is, how do we find m? Okay, what is m? We know that m is dy by dx. Dy by dx. So how do we find this tangent line? This equation of the tangent line, it is given by this thing. Okay, dy by dx, it is given by this dy by dt and dx by dt. When we substitute these derivatives here, we get dy by dx. But there is a condition. What is the condition? The condition is the following, that the derivative of x with respect to time t, it should not be equal to 0. If it is equal to 0, then the slope becomes infinite, or we can say we have a vertical tangent. We have a vertical tangent. We have a vertical tangent. Now let us do some condition, but before this I will discuss two different types of tangents, because we are going to find them in the next question. There are two different types of tangent lines, or you can say these are special tangents: horizontal tangent, and the second one, it is called the vertical tangent. It is called the vertical tangent. So think about, this is our circle. This is our circle, and on this circle, the tangents that are parallel to x-axis, we call them the horizontal tangent. This is horizontal tangent. And how do we find the horizontal tangent? In order to find the horizontal tangent, you need to put dy by dt equals to 0 and then solve it. It will give you these points. Okay, and if you look at the other one, for example, like here and here, these are the vertical tangents, and in order to find the vertical tangents, we substitute dx by dt equals to 0. Dx by dt equals to 0. Okay, so let us find, let us do one of the problems. Okay, this question is given to us. The question is given to us, and what we need to do, we want to find the equation of the tangent lines. Okay, let us do this thing. X equals to t square and y equals to t to the power 3 minus 3t. Okay, what will be the dx by dt? Dx by dt, it will be equal to 2t and dy by dt. The derivative of t cube, it is 3t square, and the derivative of t is 1, so from here we get 3. Now in the first question, he says that show that this curve has two tangents at the point 3, 0. Okay, what is the point? The point given is 3, 0. 3, 0. So suppose that we have some curve, and at this point we want to show that this curve has two tangents at this point. Okay, now think about this. Think about this. These are the coordinates of the point. These are the coordinates of the point. For example, x equals to 3 and y equals to 0. So if x equals to 3, it implies t square equals to 3, and that will give us two values of the time t, which is plus minus under the root 3. The second condition, from the second, you can say this is kind of a condition. If y equals to 0, then this second equation, it will give us the following: t cube minus 3t equals 0, and if we take t outside as a common factor, inside we will get t square minus 3 equals 0, and from here what do we get? T equals to 0 or t square minus 3 equals to 0, and this again will give us the same values of t, that is plus minus square root of 3, plus minus square root of 3. So now for example, at t equals to 0, so if I put t equals to 0 in this dx by dt, it will become 0. Okay, it will become 0, which violates this condition, dx by dt not equal to 0. So it means that at the point t equals to 0, you can think about this in the following date. At the point t equals to 0, we are going to have a vertical tangent, at this point. Now consider the second point, t equals to square root of 3. Now what is dy by dx? Dy by dx is equal to 3t square minus 3, and what do we have here? We have 2t. Now if I substitute this value of time t, it will become 3 into 3 minus 3 divided by 2 square root of 3, and then it becomes 6 over 2 square root of 3. This 2 cancels with this one, and then it is equal to 3 by square root of 3, which is equal to under the root 3. So this is our slope. Okay, this is our slope, and now we can find the equation of the tangent line. Y minus y1 equals m into x minus x1, and that will give us y minus 0 equals under the root 3 x minus 3, and it becomes y equals to square root of 3 multiplied with x minus 3. So this is our equation of tangent line, and similarly on the same steps you can find the equation of the tangent line at the point t equals to minus square root of 3. T equals to minus square root of 3, and then do the same thing, repeat the same thing. Now look at this second part of this problem. In the second part he says that find the points on the curve where the tangent is horizontal or vertical. Okay, where the tangent is horizontal or vertical. So one thing about remember this thing, for horizontal tangents, we know that what is the slope of a horizontal tangent? For the horizontal tangent, the slope must be equal to 0. So it means that whatever we have at the top, that is dy by dt, it has to be equal to 0, and that will give you this equation 3d square minus 3 equals to 0. And from here this can be written in the following way: 3d square, you can take but 3 is not equal to 0. It means that t square equals to 1, and it means t equals plus minus 1. Now we substitute these values of the time t, that is t equals to 1 and t equals to minus 1 in the parametric equations. So since x equals to, what is the value of x? The x is equal to t square, and y equals to 3, y equals to t to the power 3 minus 3t. So when I put t equals to 1 in this one, the x becomes 1, and what is the value of y? Y becomes 1 minus 3, which is equal to minus 2, and together it will give us the point A, and its coordinates are 1 minus 2. 1 minus 2. And now if I substitute x equals to t equals to minus 1, the x becomes minus 1 square, which is equal to 1, and y becomes minus 1 to the power 3 minus 3 multiplied with minus 1. And if you simplify this thing, we get minus 1 plus 3, which is equal to 2, and together these two, they will give us the point whose coordinates are 1 and 2. So these are the two points where we have the horizontal tangents. We have horizontal tangents. The next thing we will do is to find the points where we have the vertical tangents. Vertical tangents. So in order to find the vertical tangents, what you need to do, in order to find the vertical tangent, you have to substitute the derivative dx by dt equals to 0. So it means that we are going to put 2t equals to 0, and it will give us the point, the value of the time t equals to 0. Now we put this time t equals to 0 in the equation of x and in the equation of y. Since x equals to, we know that x equals to t square, so when I put t equals to 0 here, the value of x becomes 0, and our y equals to t to the power 3 minus 3t. When I put t equals to 0 here, the value of y becomes 0. So this is the point 0, 0. So this is the point 0, 0 where we are going to have a vertical tangent, and I will draw here, I will give you the point, the sketch of this thing.